Okay. All right. Wow. Rawson was even here before me. Nice. Good evening. How are you doing? Um. Okay. Today is Friday, right? Friday used to be those days where you relax and you kind of, enjoy a cold air. Well, nowadays, Friday is just another day. You're just working. You're grinding, grinding, grinding. And yeah, I mean, hopefully the grind pays off, right? Okay. Um Actually, I don't want to do trees today. Because I did not first of all um I did not have any questions for trees. I didn't study anything for trees today. I just have bare time, right? Like it's just really small. But what I did was to revisit some question on linked list. Um, Linked list is basically the same as trees, but um, with a little difference, right? Then there is a question. There are a couple of questions in linked list that I really, really, really got frustrated with when I was solving them at first, and I remember those questions. And I thought maybe, yeah, why not go through those questions once again to see if I could solve them. Again, it took me about um, 15 to 20 minutes to solve a question I solved previously. So, which means I really need to revisit the question and understand it properly. Now, the question I'm talking about is this reverse linked list 2. This question, I don't know. There is something about this question that I'm just beginning to discover. Even the whole linked list itself, right? Modifying nodes in a linked list is really not the way we actually think about it. Now, I'll go back to explaining what I meant by that, but it's just I don't know. I just discovered maybe I didn't truly understand what linked lists really are. Now, don't get me wrong. I can implement a linked list. I can reverse a linked list. I can do, everything with a linked list. But there is still one piece that was missing, which is the pointers. How the pointers, you know, are I won't say managed, but like how they really work in terms of, changing the directions and so on. It's just weird, right? And looking back at this, I just thought maybe there should be I don't know, a revisiting of OOP, right? Really understanding how, you know, when you create a class and you have nested child or nested nodes in the case of linked list, right? You have nested node. When you say a node dot nest, right? When you do this, let me remove all of this. When you do when you say we have a linked list, right? Let's say 1, 2, 3, and 4. Let's stop at this point. Okay, let me give 5. When we take this node, right? This node here, this is our head. When you say this node dot next, now this node dot next has 2, right? And 2 also has 3, and so on. So meaning a node after or a node connected to another node can be accessed with the next pointer. But when I access the node after this, will this also return all the node that this this two here is connected to. If I said node at one dot next, right? Will I just get two like this, or I'll get two, or let me just put here, or two with every other node connected to it? This is something that I was really struggling with, and apparently it doesn't work that way, right? Let me put this. It doesn't work that way. When you take a node and you try to access the next node after it, it just returns the next node, right? It doesn't return all the node connected to that node, which I think is weird, right? And I really want to, dive deep into that concept and understand it properly, because it seemed to me that I was thinking about this the wrong way. All I knew was that when I take a node dot next, right, it should return all the node connected to that next node, right? So in this case, if I had one dot next, right, it should give me 2, 3, 4, 5. But apparently it doesn't work that way, which is what I found out solving this question. This question is notoriously confusing in a sense, but if you had solved it before, you would know what to do, right? You know your way around it. But it's still not enough, right? It's still not enough. And I'll use the concept of reversing a normal linked list, right? To really go into how the pointers work in the nodes, right? So let's take a look at an implementation of a linked list. In fact, let's just implement one just for the sake of it. Um, okay, look, you know what? Let's go here. Now you can see we have a this a tree. Let's look at a linked list. Linked list. Where's the linked list? Linked list basics. Yeah, okay. So here is a basic overview of a linked list and some operations within a linked list, right? So we have um, adding items. I'll call this add node, right? You know what? Let me just quickly implement this and show you how it is done. So a linked list is made up of nodes, right? So I'll say class node. This node here is going to be equal to, so we'll define a function, and this will need a value. This will need a value, and we will do this. We'll say self dot val dot, we need a next pointer. Next is going to be equal to none at first. Sorry, none. And we need self dot value. I'll just call it val, and this is going to be equal to the value here. So we need a node, that's our node class. Now we need a linked list class, so I'll call this linked lists, and we need a constructor function, so this is going to be init, and so we need a head for our linked list, so self.head, come on, is going to be equal to none at first, and let's define a function that adds node to our linked list. So this is going to be, I'll call this insert node, and this will take a value, because to insert a node we need a value for our node. So I'll call this val, and I'll create a new node, right? So you can see, if you remember very well, this is something similar to trees. So we'll create an instance of our node class and we pass it the value. Now here's what we need to do. We need to check if the node, if our root node in the linked list has a value, right? So say if self dot root, I'm saying root head, right? I'm just confusing the terms with trees. Sorry. So if self dot head is none, right? So if there is no node in the linked list, then we need to create the head first, right? So say self dot head should be equal to our new node, and we terminate this function here. So we just return. Otherwise, if there's a head, then here's what we need to do. We need to take that head, right? We'll say call this current node. Sorry, current. Oh, my mic is blocking me. Current node. So this is a current node, and we'll set to the self dot head. And here's what we need to do. We'll start iterating, right? Traversing the nodes from the head all the way to a point where we don't have a node, which means we are the tail node. So we can do something like this. Say current node, while current node dot next, right? Meaning while the current node has a next value, then we can just say current node should be equal to the current node dot next. Otherwise, if there's no more values, so we'll say current node dot next should be equal to our new node. Okay, and this is how we can insert nodes in the tree. So let's write a function to print the node. So you know what, I'll write this function outside. So I'll call this print. Let me write it like this. Okay, I'll say print nodes, and this function would take the head of the linked list we want to print. So I'll just call this head, and I'll add a type to it. And here's what we need to do. So we'll take this, and let's say current node again. I like using current node because it just gives you the idea that the node changes, but it's still the current node that we are at, right? So the current position in the linked list. So I'll say this is head, right? We set it to the head, and we'll say while there is a current node, then we can just do this. We can say print current node dot value, and I want to end this with an arrow so that we have sorry, we don't have value, we have val. So end this with an arrow so there is like a connection between the nodes when they are printed. And we can just say current node dot next. Sorry, current node is going to be equal to the current node dot next. All right, so with this we can print every node. So I'll create a function. I'll create a value variable, or let's call this values, and set some values in it. I'll say 1, 2, 3, 4, 5, 4, and then 5. Then I'll add all these values to our new linked list. So let's create an instance of the linked list class. So I'll say this is the my linked list, or let's call this list, and set this to be equal to linked list here, like this, and iterate through this value. So say for value in values, right? Then let's add these values to the linked list. So list dot add, sorry, this dot insert node here, insert the value. And here's what we need to do. So to print this, I'll just say print node, not print, is print. So print nodes, and then I'll pass it the list dot head. Right, so let's run this and see if this works. Okay, it works just fine. All right, so we have all the nodes. You can see they are connected to one another now. And here's what I'm really concerned about, right? If I did this, if I print um let's say I did print node and I say list dot head dot hold on. Okay, let's say print, let me remove this, right? I'll print a new line here. I'll call this, oh sorry, it's the other way around. Okay, and I did this print list dot head dot next dot value, right? Let's just print this. Hold on, what's going on here? Oh sorry, I don't have value, is val I have. So let's see. Okay, this will return 2, right? So this node here is going to be equal to head.next is going to print this, which is 2, right? So you know what, let's print this out instead. So head.next, I'll copy this, I'll say next after head, right? After head, let's call this, okay, all right. I like to use this next after head and set this to equal to the node after the head node, right? I just really want to verify something. So let's say print node next after head, right? Now you can see it starts from 2 all the way to 5. Now what am I really driving at? My point here is the confusion I'm having now is when I take a node, right? When I take a node, say 1, or you know what, let's take this node 2. The next node after 3, after 2 here, where's my pen? Let me erase this part. The next node after 2 should be 3, right? Which is this node. But in my mind, I'm still thinking the next node after 2 should be all the node going down. Even if it's not directly connected to 2, it should be the node, every node down up to the node, up to the last node in the list, right? Which is becoming confusing the more I think about it, because why is, you know, so here is my solution to this question. We'll come back to this question, but the confusion was started from this question where, you know, the next node was easily modified, right? So let's say I did this, I change the next node after 2, let's say 2, right, dot next equal, let's say 7, right? And I'm still able to get 4 and 5, right, connected to this 7 here. You see what I mean? Like it's beginning to confuse me. So meaning if I took 1 dot next, right, or 2 dot next, I'm only getting 3 out of it, right? I'm only getting 3 out of it. So instead of, you know, thinking 2 dot next will be equal to let's say 4, oh sorry, 2 dot next is equal to 3 and 4 and 5 all the way down. 2 dot next is simply equal to 3. So I'll put this to the test again and change the next value of this node here and see if the same thing will be printed out. So instead of saying the this head after, okay, so this is the node from 2 down, right? I'll do this, I'll say let's print out this. I'll say node, node, next after head, right? Um, dot next should be equal to node 8. Let's see what will happen if we print when we print next after head. Now you can see everything changes. So meaning I was actually right. If we take a node next value, right, it means we are taking every node after it, even if the node is not directly connected to this node. As long as the node is a next child after a next child to the next node after 2, right, that node is also in the next direction of 2. Meaning if we take a node after 2 and modify that node, then all the node after it will be removed. So the direction of 2 will be changed, right? Now, okay, that is cleared. So let's go back to this question and I'll read the question for us to really understand what is happening. So given the head of a singly linked list and 2 integers left and right, where left is less or equal to right, reverse the node reverse the node of the list from position left to position right and return the reversed list. Now here is where things become interesting. We want to reverse. We know normal reversal of nodes in a tree in a linked list is done by setting the beginning of the list to the end of the list. In other words, the head node becomes the tail and the tail node becomes the head, right? So that process is quite straightforward. But when we are reversing the node inside the entire list, right? Let's say we are reversing in the middle. We are reversing the nodes in the middle. Then things become a little bit confusing, right? Because not only that it is difficult to even know where to start the reversal from, although we are giving this left and right values, right? But then we still need to know where to start it from. We can't simply say, oh, okay, we are always sure that the left node is going to be a value or a node other than the head node, right? We don't really know. We can be asked to reverse the node from this point, right? Let's go point at the first node in the tree, in the linked list, in the list or any other node in the list, right? So it is not guaranteed where left or the value of left will be, right? So in this case, we really need to be careful how we start the reversal. Now, the reversal will begin at a position on the left, obviously, but we need to know how to point to the left, right? We need to know how to choose where the left really is, which is why we have to create a dummy list. Now, the dummy list will help us separate the entire list from one particular point. I'll take this image here. Okay, it's still the same thing, right? It's still 1, 2, 3, 4, 5. And we want to reverse from this node, which is left is here. Left is equal to 2. So the second node in the list. And right is here, right, which is 4. So R is equal to 4. R is equal to 4. So we want to reverse this node in between such that we'll return, I think 4 will be here. So let me use the same color, right? We'll have 4 here, we'll have 2, 3 here, and 2 here before we have the last node, which is 5. Now, I talked about a dummy node, having a dummy node and everything regarding that, but let's look at that in practice, right? So here is what needs to happen. the dummy node, right, will really help us. It's just an uncertainty, right, that the left node will always begin at a node after the head, right? Meaning, you know, we can have left equal to 1 at some point, right? Which means we'll have to reverse every node from this node all the way to 4. So for us to be able to for us to account for that, or to be careful with cases like that, we need to create a dummy node. Now, our dummy node is what will return at the end of the day. Is the head of that dummy node will return at the end of the day. So here's what we need to do. Instead of having the list like this, we'll modify the list, right? And we'll have a new list that looks like this. So we'll have from so our dummy list will have a new head, which is 0, right? And then we'll go, come on, 0, we'll have 1, we'll have 2, we'll have 3, 4, and 5. Now we are sure to be able to get every node, even when the node is equal to 1, right? So how do we even do that? Well, so for us to point to the node from which we start reversing, right, we need to iterate up to that point. We need to leave a mark or a pointer at that position, and then start the reversal from there onwards, right? So let's say in this case L is equal to 2, right? So we'll move a pointer towards this point. So we'll start L is equal to 2, meaning we'll start the reversal at this point, but we'll move a pointer from this point towards this point, right? We'll move a pointer from this point to this point here, from the node at 0 to the node at 1, right? And then we get the values from this point onwards. So we'll say this node here dot next will give us this node. Now, before I even continue with this, right, I think I need to show you guys how the reversal of nodes in a linked list is done. So it's just a quick recap. So here's what we'll have. Let's say we had 1, 2, 3, 4, right? 1, 2, 3, 4. This is our node currently. This is the original form of our node. So the reverse form of this will have 4 as the head node, then followed by 3, followed by 2, and followed by 1. Now we know the last node in the linked list is always pointing to null, meaning our head node will start pointing to null at the end of the day, right? So let's quickly implement that and see why we had to start the reversal from this point, right? So let's take a look at an implementation of a linked list. Where should I do that? Reversal, right? So I'll write a function to reverse the linked list. So let's say, hopefully I remember how to do that. So reverse list, right? This is a function. Obviously we will need a head. This is going to be equal to an instance of a node class, and here's what we need to do. So the reversal will happen this way. We'll say we'll have the head again using current node. Current node is going to be equal to our head, right? And the next thing we need to get is a null value, right? We'll call this priv. Priv is going to be equal to none at first, and we'll begin to traverse the nodes in the list. So we'll say while current node, right? While current node has okay, while current node is not null, right? So we are trying to reverse, so we are pointing new values to the node. Okay, while there's a current node, we can say the next node is going to be equal to the current node dot next value, right? Current node dot next, and we say current node dot next becomes the previous, meaning the head node will now become will now point to none. Previous is none at first. Previous becomes the current node, right? And current node should be equal to the next node, right? So yeah, and then we return the head, right? Let's just return the head at the end of the day and see what this gives us. So I'll reverse this node here. Let's comment this out. I'll say reverse list, and I'll pass this list here dot head, okay, and sorry, reverse list. You know what, let's reverse it here. Since we are returning a value, I'll say reverse rev list, and this is going to be this, and I'll print this node here. So I'll say print rev list, print node. Yep, rev list. We're returning the head, right, which is a node. I don't know why this is not working. Okay, I don't think so. This is pointing to head. What's this? Print node ref list. Hold on, I hope I'm not making a mistake. Let's take a look here. Get position, insert value, reverse. Okay, yeah. Oh, you see, I'm doing it wrong. Instead of returning the head, I'm supposed to return the previous node. Okay, so that's better. Okay, this still didn't work. How do we print it out? Okay, so rev.head, right? Revlist.head. You know what? This is not what I was expecting. So reverse link list the head, print link this reversed. What's happening? Dun dun dun. While the current node is not none, which is also the same as while current node, next value is the next node value. Current node, yes. Current node dot next value. So why is this not working? Hold on. You see, this is what I was doing. Oh, I wasn't even calling the actual function. That's really funny. Anyways, okay, so something still broke. Don't know what, but you know what? Oh, you see, the release was already reversed here. Christ, let's run it again. So now it works. So this is the reversal of the list, right? Now you can see how the reversal of an entire list is done, right? We first of all took a previous value, right? We took a previous value and we set that previous value as the next value of our current node. Now, our current node is simply the head node, right? In this case, it will be the head node. At first, in the first iteration, it's going to be the head node. We set the next value of that node, right? We set its next value to the previous, which was none initially, right? After the first iteration, previous becomes our current node. In other words, previous will become 1 and 1 pointing to none, right? Which is why we return previous at the end of the day, because previous will hold the last node in the list, which is going to be the node before current becomes none, right? So which is going to be 5. So when we print from 5, we'll have this. We'll have 5, 4, 3, 2, 1. So reversal of a node is basically changing the next pointer of our current node to a previous node, right? So coming back to our question, we want to reverse the nodes in between the list. We are no longer reversing from the beginning to the end, right? Which is kind of difficult. Yes, I agree. It is difficult. At least it's difficult for me. But, you know, here is what I did, right? So, I first iterate from the beginning of the list, which is our fake node, our fake list, right? I call this fake node, or you can call it a fake list. But basically, we're creating a fake linked list and setting a fake value as the head, right? Then we iterate to point to the node before it. So we want to know where we are starting from. Just like in the case of a normal reversal, we start from the head node, right? But this time around, we want to start properly at the head node. And there is no way for us to actually point to the head node directly. We can't say, oh, list at number 2, right? We need to traverse the entire list and stop at that particular point, right? Which is what is done here. So we stop at 1 less than the left node, meaning if this was our list, we'll stop at this point here. Let me remove all of this. If this was our list, right, we'll iterate from the beginning here. We'll start from this one and traverse up to this point. We'll stop here, right? This is our mark. This is where we stop. So now we need to take, let me bring this back. Okay, so hold on. This question really messed with me, but I really have to unlock this. So we need to iterate from this point all the way here and then take the next pointer of this node, right? So we'll reverse everything from this point going forward, right? Maybe we stop at this point here, which is this 4. We reverse everything and connect it back to this node at 1 here, right? This node here. This is another reason why we have to iterate up to this point, right? We have to stop here because we need to connect the reversed version back to this node. So the next pointer after this will be 2, right? So this is going to be 2. And so from 2 going up to 4, because our iteration has to stop. So the value of the right input here is 4, right? So meaning we are iterating from 2 to 4, and then from 2 to 4 we know the distance is going to be equal to 2, so we need to do left minus or right minus left, right, which is equal to 2. So 2 iterations to reverse or to swap every node in the list and connect it back to this point. Now, how is that going to do? This is where my biggest confusion started from. So let me remove this. We know we stopped at this point, right? So we take this next node. So our next node here will be equal to 2, from 2 all the way down. Now, when we change the next pointer of 2, right, it means we will lose everything going down, right? If we say 2 dot next is equal to, let's say, 5, right? Or 2 dot next is equal to 4. Let's use a node in this tree, in this list. If we say 2 dot next is equal to 4, meaning 2's pointer will point to 4, right? So this also means that everything after 2 will be forgotten. Even this node here will not remember it, right? And yet this still worked. And I still don't understand why it worked, right? If you look at this very well, you can see we set temp to the node after left, to the node at left. So let's say node at left is node before left dot next, which is, this is node before left, right? And node at left will be equal to 2 here. So node at left will be equal to this 2. So this node, we take this node and we take the next pointer of this node. So this next here will be equal to 3 all the way to this point. So let's do that. So 3, 4, and then 5. I'll just take it like this and keep this down. I'll say this is equal to temp, right? Temp is equal to this. And so if this dot next is equal to the temp's next, meaning 2 will point to temp dot next. So this is temp, right? Temp dot next will be 4, 5, 4 to 5. So 4, 5, right? So then we take, so we what we did now is that we took from 2 all the way to 2 to 4 to 5, right? And then we removed 3 after 2. We separated it into temp, right? And then we took this value out of the list, right? And what do we do next? So we take temp dot next and set it to the node before left dot next. Node before left is this. Is 1, yeah. So is this node here? Node before left. Left is at this point. Node at left is this one. So node before left dot next will be from 2 down, right? So 2 so node before left dot next has already changed to this, right? So we set the temp to be equal to the node temp dot next to be equal to node before left dot next, right? Or node before left. Yes, node before left dot next. So node before left dot next is this node here, right? Node at left, which is also from this point here. So we take this, right? So we set this to, so this will become 3 will point to 2, 4, 5, right? 2, 4, 5. Okay, so then what do we do there? So we'll connect this back to the tree, the original node at left, right? So node before left or next will become temp. Okay, so this is beginning to make sense now. Maybe I was just agitated and didn't take my time to understand this. So node before left will be this, will be 1, right? 1 will point back to 3, 2, 4, and then 5. So we will do the same thing again because we are iterating twice, right? So left minus right. So that's the first iteration. In the second iteration, we'll do this again. So we'll take a temporary node. I'll use a different color. So temp will be equal to, so the node after this, right? Because, okay, node at our node at left, right, will be 3 now. Node at left will be 3. So we take 3, every node after 3 will be equal to our temporary node. So it will become 2, 4, and 5, right? So this is the temp node, and then node at left dot next will become uh, the node after temp, right? The next node in the temp node. So node uh, node at left dot next will be equal to the temp node, so which is going to temp dot next, which is going to be equal to 4 to 5, right? 4 to 5. And what do we do next? So after swapping, we then take this and connect it back. So this will be temp dot next will become node before left dot next. So temp dot next, so temp dot next will become node before left dot next. Temp dot next will be equal to node before left dot next. So node before left dot next is this node here, right? So node before left dot next will be temp dot next. So this will become so temp is this. So this is 2 hold on, temp dot next, right, is 4. So node before left dot next. Aha. Okay, so this is where I begin to confuse myself. You see, I copied node before left is this way, this point here, right? Node before left dot next is this, which is 3 here. So temp dot next becomes node before left dot next. So this will become 4 connected to 3 connected to 2, like this, and after 2 we have 5, right? So this will be 5. Then we connect this back to the node before left. So we'll say node before left dot next will become all of this, like just like we did it here. So it's going to be 1 connected to 4 to 3 to 2 and back to 5, right? So is this how we reversed it? So 4 3 2, right? 4 3 2. Okay, so all this swapping happened within the fake node, right, or the dummy node we created, which started from 0. Oh my god, I did not check my time, nor did I check the chat. Oh wow. Let's see what's in the chat. Ha. Hey, hello Dan. Oh my god, I did not know. I didn't see. Hello Rosemary. Wow. I wasn't checking at all. Sorry. It just really became personal, and I wanted to understand this question very well. How are you guys doing? Dan, have you solved this question before? Hello, Said. Hello. Hello, everyone. Has anyone solved this question before? I genuinely want to know, how you did it, because my steps were just. I think I did. I was just doing what I could, and yeah. So okay. So let me leave the chat here, and my time is even almost up. Wow, that's interesting. I've not done this before. Oh, you know what? Let me add 15 more minutes to the time, just for the sake of it. So we go a bit longer today. So yeah, cancel this. So there was let's do 25. 25. Okay, 25 minutes. 25 more minutes. Yeah. Let's bring this here. Let me refresh. My chat is really slow. I don't see the message early. Oh God. You said to not be shy. um. Okay. So. Said, if you are studying programming, data structures, and algorithm, anything at all programming related, you can join the Discord server. The Discord server link is on my channel. You can join the server to interact with other like-minded people. Yes. You know, there are a lot of people, quite a few people on the server, right? So you can join also to study with us as well. And if you have any question, you need help with anything, you can ask, and somebody would just be there to help you out. All right, so let's get back to the question. I like and hate this question. I like it because I don't like it. And I hate it because I don't like it. Yes. So that's exactly how this question makes me feel. You think you understand what I'm saying, but you don't, right? So, um, okay. I think, I think I need to, I need to really, I will need to look at this question in my dreams, right? I should just sleep and just see the question and solve it in my dreams. Then I will know for sure that I now understand this question. I get what has to be done, but let's say we are given three cups, right? Now this is this is totally unrelated, but this will help us understand something. I think I should just do it this way. Say we are given three cups, right? Five cups. So this is another cup. This is another cup here. So one, two, three, 4, and 5. Now, this cup, these cups are arranged on the table, and we have to swap the cups, right? We have to swap them without actually moving them, right? So let's say we have to swap these cups. So this is our red cup. This is our blue cup, right? And here is the green cup. I'll put the green cup here. So this is what this question is asking us to do. And yeah. So now since these cups hmm, are on the table, we want to swap them, right? We want to swap three cups with just two moves, right? We just have to swap them twice so that we end up with something like this. We end up with something like this. Sorry. I'll draw the cups again. This is one. So the green cup will be here. Two moves, right? The green cup will be here. Then we'll have the blue cup still here and the red cup after. Sorry. So the red cup will be here, and the last one. How do you do this? How do you swap this with just two moves? I think this is what the question is really saying. I'm just trying to reform the question into a different question, right? So if we label this, okay, who in the channel can swap the cups, right? With just two moves without moving all the cups. You can just swap them with two moves. Swap three cups in between here and here, right? With just two moves. You make two moves and that's it. Does this even make sense? Is this possible? I'm drawing cups. Oh, okay. They are different colors. I'm just trying to identify um the colors of the cup. Can these cups be swapped? Right? This is a cup of tea. Okay. Well, can you swap the cups with just two moves? Three cups with just two moves. Is that possible? Oh, I think it is possible. That's really, you know. Anyways, you can swap it, but how do you do it? I don't know. I don't know. Yeah, maybe we should start a cup business. Solving data structures and algorithm questions. I really like this question, and at the same time, I really don't like it. Um, Dan, have you solved this question before? Dan has solved more lead code questions than me. So Dan is really good at data structures and algorithm than I am. So um oh, I can stream to Discord. I can stream to Discord. I didn't know that. Dan has probably solved this question before. Wait, let's see. Can I do this on Discord? How do you do? Oh, okay. You know what? After the stream, I think I will open a new stream on Discord, and Dan will explain this to me. I I know what has to be done. It's just like I memorized my own solution, but then I still don't. I have no clue, right? I know we have to swap the nodes by just changing the pointers and then connecting them. Oh, wait, I don't. Let's see. It says I should stream this. I don't know how you stream on Discord. How do you stream on Discord? Let me search it. How to stream on Discord. Come on. Um, join the voice channel that you have permission to stream in. Uh, oh, okay. Click the screen. Let's see. All right. Okay, it becomes interactive. Okay, let's see. Let me open Discord now. Um, it's question number 92 on Lead Code. Reverse linked list 2. Reverse linked list 2. Where is my Discord? I don't know why Discord is not opening. What's happening with Discord? Come on. Do I have Discord open somewhere? Oh my god, I can't find Discord. I can't find it. Where is Discord here? Wow. It's not opening. Literally, it is not. Just watch. I try to open Discord, right? I don't even have any instance open, so I can just literally open one. But it's not doing that. I don't know. Maybe it's because OBS is opened, which would be strange, right? Because OBS has nothing to do with Discord, so why is it not opening? Ah, it's annoying. Dun, dun, dun. Wow, 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 wow. Discord has failed me today. Let's see if I have Discord opened somewhere. Okay. Can check throughout this place. App startup. Oh no. App history. Do we have Discord here? So I've ended every instance of Discord. Maybe it's open somewhere in my tabs. Other on other desktops. I don't know. But let's see. Let's see. Da da da. Okay, Discord is opening now. Ha ha ha. Yes, it is opening. Just hold on and see magic. The magic is about to happen. So, oh, shouldn't get too excited now. Should I get too excited? Yes, I should get too excited. Okay, so here's my Discord. Come on, come on now. Go here, go to this part. Okay, so let's see. We have uh okay, okay. Right. Okay, let's see. So let's see. Well, what I did here is really simple, right? So you just go to your tasks and check all the processes you have opened, right? And then you close some of them. Then all the instances of any app will be closed on your desktop. It's really my computer is really making a lot of noise right now. I have a lot of apps opened. Oh, okay. So let's close that. Um, let's see. Where do we do this? Is it in the voice? How do you stream to get Discord? Now I'm confused again, right? I don't even know what to do. Let's read this. Go live. Click on go. You see, go. Okay, join a voice channel. You have permission to stream in. Click on the screen button at the bottom of the screen. Okay. So let's go to okay, voice channel. We have a general voice channel, right? And then I can click on what? Click on the screen. Share your screen. Am I sharing my screen? Whoa, 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 whoa. This is not good. Let's go back. Let's go back. Screens. I'll share screen 3, screen 2, screen 1, screen 30, frame rate. Are they asking me to pay to stream my own, to share my own screen? So, okay, if you select video, your webcam will stream, blah, blah, blah. So, okay, let's go live and see. Can you guys see my screen? Can you see my screen now? I think I can see my screen. Let me. You can talk in the channel. I think you can. Dan should join the stream. I'm waiting for Dan. Streamer mode enabled. Okay, okay. I'm streaming on Discord. Yeah. Yeah, yeah, yeah. Oh, it works. Can somebody say something so I can hear you talk? Okay, ransom is here. Ransom is here. Cool. Nice. Stream setting, stream quality. You know what? This is good. Discord is great, right? So what do we do now? What do we do now? Oh, wow. It's amazing. Okay. Looking for something to do. Start streaming. Okay. I think Dan has gone off. Because I can't see Dan anymore. Anyways, we continue tomorrow. Or you know what? Christ. I hate to leave. Well, I got to leave. So everybody has made me. You guys are really funny. So nobody is in the stream. Okay, okay, nice. I think you can run classes here, right? But do people subscribe to streams on Discord? Kind of new to Discord, right? Let's see, let's see, let's see. Okay. Oh, all right. Um, you know what? I'm done for today's stream. But let me go back to this question once again, and let's see what's happening here. So we take temp takes all the node after this node, right? And then we set the next value of this to temps next, and then temp changes temps dot next becomes this, and then we connect this back to the beginning. Okay, so um I'll look into these things again, and tomorrow I'll be streaming in the morning. I need to stream in the morning tomorrow. So I think Dan is in the stream now. So anyways, live. Is there a board in Discord? A board to write on? There is no board. Hey Dan, how you doing? Yes, you are audible. I can hear you. Dun, 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 dun. I can hear you, Dan. Okay. It was reverse linked list 2. Reverse linked list 2. You can see it on the screen. I think I have to end the stream on YouTube first, because my computer will just melt down. It's taking a lot of, my fan is really blowing hard now, so I need to end the YouTube stream. So we just do this one maybe for like 10 minutes. So yeah, let me end the YouTube stream.